Yeah, brilliant. Cool. So, yeah, thanks for having me, everybody. And yeah, tonight we're going to be talking all about Blazor and why it's so exciting. Um, so, as well, I don't know if anyone's noticed, but there's a special guest in the room as well. Mr. Daniel Roth, the PM for the Blazor team, is in the meeting as well. So, if you've got any really difficult questions at the end, I'll leave those for Dan. I'm sure he'll enjoy those. So anyway, let me just crack on. I'll introduce myself first. So my name's Chris, and I'm a lead software engineer and a Microsoft MVP. I also do a lot of blogging. I've been blogging for a couple of years now on my blog about Blazor, pretty much since it first started and I discovered it. And I've been quite lucky to be able to blog about it for a few different places. I've written articles for Visual Studio Magazine and Progress Telerix blog, and most recently for Stack Overflow as well. So that's been keeping me fairly busy. And then I also do a lot of open source work as well. So I've got an organization on GitHub that I look after called Blazor, and we create a load of open source packages to help you build your Blazor applications a bit quicker. So we've got UI components on there, things like modals and toasts and stuff like that. And we've also got some helper libraries as well, which is hopefully going to be useful to you. So please check those out if you're doing any Blazor work. So for the talk tonight, this is kind of an introductory kind of talk, but it does go into sort of the architecture of Blazor and how things work under the hood. So hopefully it will be interesting for everybody, no matter where you're at on your Blazor journey. So we're going to start right at the beginning. So what is Blazor? So Blazor is a framework for building single page applications. Okay, so Blazor's main goal, I guess, is to be a competitor to the likes of Angular or React. For the .NET world. So Blazor was a brainchild of a guy called Steve Sanderson. So if you haven't heard of Steve before, he works on the ASP.NET Core team. Very smart guy. He's got a great pedigree in this area. He's responsible for Knockout.js. Steve, I think, originally showed the prototype for Blazor at NDC Oslo in 2017. It's a great talk. It's available on YouTube, so definitely go and check it out if you've not had an opportunity to. Funny thing is, I think Blazor was only one of 4 things he actually showed in that talk. So yeah, it's definitely worth checking out. In terms of technologies, well, we use Razor to build Blazor applications, and Razor is a mix of C# and HTML and CSS. If you've done any work with Razor pages or with MVC, this will be very familiar to you, which means that the learning curve of Blazor should be pretty shallow for you, which is always good. Like other front end or single page application frameworks, Blazor applications are built using components. This is a pretty common way of building UI nowadays. React, Angular, Vue, they all take this approach, and Blazor is no different. Blazor uses a concept for its virtual DOM called a render tree. So again, all these modern single page application frameworks have this virtual DOM representation, and that's because updating the actual DOM is quite an expensive operation. So you tend to have a virtual version because you can kind of run diffs against that and calculate the minimum amount of changes you need to do to the real DOM to make things as efficient as possible. And I suppose most importantly, it works in all modern browsers, including mobile. So you have to go back as far as, I think, IE 11 before you're going to find stuff that doesn't support Blazor. But even then, you can use JavaScript shims to get applications working. So I've seen people successfully run Blazor apps on IE 11, IE 10, and stuff like that. So it's been some weird and wonderful stuff, especially really early on. I'm sure I saw someone running it on like a clone of IE8 or something really mad like that. So yeah, so you can definitely get it going on some older stuff as well. So in terms of features, these are some of the things that Blazor gives us out of the box. So we've got forms and validation, which is pretty central to most web applications. There's not a lot we can do without being able to take some input from the user and validate it. We've got code sharing with Blazor. Now, this is a really big deal, especially if you're running C# on your back end. So with Blazor, we can now run C# on the client and on the back end, which means we can share code between the two using net standard class libraries. I've worked for .NET shops most of my life, and usually we end up sort of more modern stuff has always been done with .NET web APIs on the back end, and then something like Angular or React, whatever, as the front end client. Now, I don't know about anybody else, but I've lost a few hours here and there to debugging where someone's got the TypeScript model out of sync with the C# model or something like that. But with Blazor, that is a thing of the past. You can put those shared models into a class library, reference them from both projects, and you're done. Make changes in one place and that's it. So security is in Blazor out of the box. So we can we've got templates available now actually, where we can actually just tick boxes to turn on certain security features. We can do applications secured with OIDC now with Blazor WebAssembly and things like that. We can do stuff integrated with Windows Auth, with Azure AD B2C. So that's all available as well for you with Blazor. We have pre-rendering. So with Blazor Server, pre-rendering is turned on by default. We can also do pre-rendering with Blazor WebAssembly apps as well. The caveat for that is that we need to be using the hosted template in order to do that, but it's perfectly possible. So if SEO is important for your application, then you can get some positive wins there with Blazor. Dependency injection. If you've done any work with ASP.NET Core, then the dependency injection is the same in Blazor. So if you've done, let's say, any work with Razor Pages, MVC, web APIs, things like that, this will all look very familiar to you and you'll be very at home with Blazor's system. We can create component libraries as well with Blazor. So we can use something called a Razor class library to package up components and share them between applications in our organizations, for example, or we can even bundle them up into NuGet packages and share them with the wider community on NuGet as well, really easily. And probably another really big one that possibly doesn't get shouted about so much is the .NET ecosystem that we have available to us with Blazor. Most new frameworks have got to wait for some kind of ecosystem to build up around them. But that's not the case with Blazor. If NuGet packages are targeting .NET Standard, then within reason, we can use them within our Blazor apps. You can just install them, configure them, and get on with it. And that's a massive win for Blazor apps because there's a huge amount of great resources available on NuGet, and a lot of them are available to us for writing our Blazor apps. We've got great tooling and debugging as well with Blazor. So with the latest preview, we got debugging in Visual Studio for Blazor WebAssembly, which I think was a massive win, and everyone in the community was really, really happy to see that. So we can just hit F5 now, set our breakpoints in Visual Studio, hit those breakpoints, inspect values, all the stuff that you would expect with the .NET application. JavaScript interop is also a feature of Blazor. So most people, when they think of Blazor, they usually think of not having to write JavaScript. But every now and then we have to. And I'm going to explain a little bit later as to why. One of the reasons as well is that there is some great libraries available in the JavaScript ecosystem, really battle tested. And, if you want to get on and build some applications that are doing things and you need to build them quickly, then, you can use the interop APIs to use those JavaScript libraries from your Blazor app and take advantage of all that development. And then finally, this one's sort of very specific to Blazor WebAssembly, but we have this concept of assembly shaking or an IL linker. And what this does is it reduces the bundle size of your app. And it does that by sort of intelligently looking over your code and basically removing everything that your application isn't using. And this is really important for Blazor WebAssembly because we download quite a lot to the client, and the smaller we can make those bundles, the better, really. So that's where that technology comes in. Cool. So now we know a little bit about Blazor. Let's start sort of pulling the covers back in and understanding a bit more about how Blazor works. So let's go grab a drink. So we'll talk a bit about Blazor's architecture here now. So I've got this sentence here. Blazor separates how changes are calculated from how they're applied. So why is this important? Well, it's to do with the way Blazor's been built. There's a separation in Blazor between its app or component model and its hosting models, which is sort of where Blazor runs and where it renders its output and things like that. And this separation seems a quite simple idea, but it's actually a brilliant decision, and it makes Blazor very flexible and gives it a lot of potential. It's one of the big things of why I'm very excited about Blazor as a framework. So I'm trying to illustrate this to you a bit more. So Blazor, as I said, it's got this app model, this component model, and by default, it ships with a web renderer. So this web renderer knows how to output HTML to a browser. So the component model is where all the diffing algorithm is and all this kind of stuff. And when that runs and calculates changes, it passes that information to the web renderer, and that web renderer then knows how to make that display in a web browser. But as I said, there's a separation there, which means we can do cool stuff like we can move it around, and we don't necessarily have to run it in the same place as the rest of the component model. So we can split this out, and we can have some on the client, some on the server, and then some kind of network protocol to connect the two, like SignalR or something maybe. The other really interesting thing is that we could then plug in different renderers. So we could swap the web renderer for a different type of renderer, something that knows how to render native UI for mobile apps, for example. And now, again, we can pass those same UI changes to that renderer, and now that renderer could possibly render a native mobile app. Okay, and more on that later. So in terms of the hosting models, there's kind of two that I'm sure you've probably heard about if you've looked at Blazor at all. Blazor Server and Blazor WebAssembly is what I've been talking about so far. So Blazor Server, this is the current production supported hosting model for Blazor. This was released back at .NET Conf in September last year. It was part of .NET Core 3. So yeah, it's been around for a little bit now. And in this model, Blazor runs on the server, and then over a SignalR connection, it establishes a connection to the client. And then any interaction that happens from that point forward goes back and forth over that SignalR connection. And we're going to go into detail about how that works in a little bit. And then we've got Blazor WebAssembly. Now, this is the one that a lot of people tend to get quite hyped about. It's the one that I think most people associate with Blazor. And this is currently in preview. We're actually coming near to the end of preview now. It's due for release in May 2020, hopefully. So not too far to go. And in this model, everything runs in the browser. Okay, so we're executing C# code in the browser using this technology called WebAssembly. And we're going to go into this one in detail as well. Now, in terms of writing components, well, this is what a Blazor component looks like. And this will work with either of those hosting models. We tend not to change the way we write Blazor components based on the hosting model. That's kind of more of an implementation detail, really. So you can see here, we've kind of got two halves to the component. We've got the top half, which is like markup. And then there we've got HTML, and we've got some Razor. We're printing out the value of current count, for example. And then we've got this interesting syntax, this @onClick, which is a special Blazor event handler for that button. So what we're saying here is that when this button is pressed, we're going to invoke this increment count method. And that's defined below in the code block. So this code block is normal C# code. We can put any valid C# we like in here. So you can see here, we've got the current count field defined, and we've got that increment count method that just pushes the current count up by 1 each time. So this is kind of the default for a Blazor component. If you want to, you can separate these two bits out, because often people look at this and kind of think, oh, I want my logic in a different file to my markup and stuff like that. So it's perfectly possible for you to do that. You can either do it using a base class, or you can do it using partial classes. So there's a couple of options there, so you can get that kind of code behind model if you want to do that. However, I personally prefer writing components like this. I think it's true as well. I think that the Blazor team would write components like this as well. I personally like it because I like having everything in one file. It makes it easier to work with. It also shows me when my components are possibly getting too big, if my file's getting too big to sort of deal with in one file. And the other thing I like it for is it really kind of reminds me that the logic here is only to do with the UI. There can be a bit of an anti-pattern with Blazor apps where people are putting too much logic into their components, too much business logic into their components. These components are UI components. They shouldn't contain business logic. Okay, that should be on your server or in a service somewhere else or whatever. It shouldn't be in your UI components. So if you think about where Blazor fits, it fits in like the view part of an MVC pattern. So the other interesting thing about Blazor components compared to other Razor flavors that we have in .NET is what happens when it's compiled. So with Razor pages or MVC views and things like that, when they're compiled on the server, they effectively output a HTML string, which is sent to the browser to be rendered. Blazor is slightly different. These Razor components actually get compiled into a class. So this particular component actually looks like this. So this is what the Blazor compiler is going to turn it into. Now I've stripped out there's quite a lot of noise in this file normally, so I've stripped all that out. So hopefully it makes it easier to understand. But you can see that in that markup section at the top of the last slide, you can see that's actually all been converted now into C# instructions using this render tree builder. You can see we've got the div and the p tag and the current count and stuff like that. So what happens here now is that when Blazor does its diffs, it runs and executes this build render tree method to create a diff, and then the algorithm compares it to the previous one and works out the minimum changes, and then it's only those minimum changes that are actually sent to the client to be displayed and update the UI there. So let's start diving, sort of deep diving into some specifics now. So Blazor WebAssembly, like I said, it's in preview, hopefully due in May. So for starters here, I'm going to talk about WebAssembly because it's just important that we cover all the bases. So if you've not heard about WebAssembly, WebAssembly is a binary code format and it's fast. So one of the big things about WebAssembly is it promises us near native speeds in the browser. So that is quite an interesting thought. There's actually some pretty impressive apps that are running as WebAssembly already. There's a UI design application that runs in the browser called Figma, and that runs on WebAssembly, which is it's pretty impressive to see that that functioning. In terms of sort of writing WebAssembly, you don't tend to write WebAssembly. WebAssembly is usually it's a compilation target for higher level languages, and that's really because of what WebAssembly looks like. So this is a C++ method on the left here, and on the right is the textual representation of that as WebAssembly. So as I said, WebAssembly is a bytecode format. So this is a textual representation of it. You can actually write WebAssembly this way if you really want to. It's not my cup of tea, but you know, some people do. So if that's your thing, then you can have at it. But usually you'd write in a higher level language and compile down to it. WebAssembly is also a web standard, and this is a really important one because usually the first thing that Blazor gets compared to is Silverlight. I can completely understand why, but one of the big differences between Blazor and Silverlight, and there's quite a few differences, is that Blazor is built on web standards, okay, not any proprietary plugin models or anything like that. And WebAssembly on the 5th of December last year was officially welcomed by the World Wide Web Consortium as an official web standard, and it is the 4th language for the web alongside HTML, CSS, and JavaScript. The other thing is WebAssembly is supported in all major browsers, including mobile ones. So again, this is quite important. In fact, WebAssembly has been around for quite a while in the major browsers, around 2 years now. So this isn't sort of some technology that came out last week or anything like that. It's kind of pretty well baked now as a MVP and things like that. And there's lots of other cool stuff coming along the way, things like threading and garbage collection and stuff like that. So this is going to be really powerful and a really interesting technology for the next 10 years of web development, I think. So how does WebAssembly fit into the Blazor story? Well, it's actually used to compile a .NET runtime. So we take the mono .NET runtime and we run it through a toolchain called Scriptum, and out the other side we get a couple of files. We get a .NET.wasm and this .NET.js file, and that is the mono runtime compiled to WebAssembly. So it's quite simple. Why mono? Well, mono is the preferred client-side runtime for .NET applications. It's small, portable. It's designed for this exact scenario, so it makes it a good fit for Blazor. The mono team had also done a lot of work, already done a bit of work into the compiling to WebAssembly anyway, so it helped give the whole thing a bit of a kickstart, which is cool. One thing that's worth clarifying at this point: your application is not compiled to WebAssembly, at least not yet. This is a feature that the team are looking into, and I think this is kind of this is possibly for .NET 5, which is November, or possibly .NET 6 the following November, but it's not going to be there for May. So what actually happens is your application just gets compiled to DLLs, normal .NET DLLs. There's nothing special about them. You could take them and run them on any .NET runtime somewhere else. They just happen to be executed in the browser on top of this WebAssembly.NET runtime. So let's talk about how a Blazor WebAssembly app actually boots up, because that's quite interesting. So we've got our Blazor WebAssembly app on the left-hand side here, and we're going to sort of go through the boot up process. So we're going to start off by making a call to the web server, and that's going to return us back some static content. So that's the first interesting thing. We're getting back static content. This is interesting. We've not had this before in .NET. We actually don't need a .NET runtime on the web server anymore with pure WebAssembly applications. And this is because when you publish a Blazor WebAssembly app, like I say, it comes out as static files, which means we can use things like free hosting. So we can use stuff like GitHub Pages or Netlify or Azure Storage. So not quite free, but nearly free. Amazon S3 buckets, things like that. Okay, so that's really cool. So once these files hit the browser does its thing, generates DOM, all that kind of stuff. And then we get a couple of files. We've got this Blazor WebAssembly.js and this .NET.js file. And what happens next is that .NET runtime gets booted up, and then Blazor's runtime gets booted up, and then your app gets booted up. And at this point, we've now got an application, a .NET application running in the browser. So what I want to point out is that on this slide, there's this green line going across the browser there. And that's just to signify that there's actually kind of two bits to Blazor. There's the stuff that we've just talked about, the WASM side of all this kind of stuff, but there's also this bit of Blazor that has a foot in the JavaScript world. And that's important because WebAssembly has an Achilles heel, I guess, for want of a better way of putting it, depending on how you look at it. It can't actually modify the DOM in any way. It can't call any browser APIs. It still has to rely on JavaScript to do that. So Blazor has a little foot into the JavaScript world in order to sort of handle that interop scenario. So cool, we've got our Blazor WebAssembly app running in the browser, which is pretty sweet. But let's talk a bit about how sort of things happen in Blazor WebAssembly apps. So what we've got here is we've got a page showing some search results. We're going to click a button to load some more, and we're going to go off to our web API to get our next set of results. And we're going to see what happens. How does all this happen in our Blazor app? So we're going to start off by clicking our load more button, and that's going to get intercepted, and it's going to get passed into our app from the bit of Blazor that sits in JavaScript, okay? And we've got our search component in our app, and that's going to have some code to handle that button click, similar to what we saw on that earlier slide when we were looking at that counter component. So in there, we might have, we're going to have an HTTP client that's going to make a call out. Now, to us, writing this code, it's the same HTTP client we know and love from .NET. But in Blazor WebAssembly, it's kind of been configured in a special way, and it actually calls down into the JavaScript fetch API to make that API call for us. So that's what's going to happen next. It's going to go down into that JavaScript layer, and it's going to make that call out through the fetch API to our web API. Our web API is then going to return back our data. And that data is then going to get passed back up to our calling code in our search component. Now, at this point, we've got a list of search results on our screen. So we're going to update that list, for example, with these new search results. So we've changed the state of that component. This is going to trigger Blazor to do a new render to work out what's changed and see if it needs to update the UI. So that's what happens next. And Blazor does that. And at the end, if there's changes that it needs to make, it collates them all together in something called a render batch. And this render batch is the minimal set of instructions that are needed to update the DOM from what it currently looks like to what it needs to look like. So Blazor is then going to pass that through to the DOM and then update the DOM so it matches this new render. And then our UI is going to update for us. So you can see here, we've now got our 4 new results on the screen. So that's how kind of a simple interaction works in a Blazor app. So talked a bit about theory. So I'm going to jump out of PowerPoint now and jump over to Visual Studio, and we'll have a look at the templates and stuff that we get in Visual Studio for Blazor WebAssembly. So let me just bring up my Visual Studio here. So if we go new project, and I've got Blazor app here because I tend to build a lot of these, and app 42, that sounds cool. So when we get to this create new Blazor app screen, we've got a couple of options, Blazor Server app and Blazor WebAssembly. Now, because we're currently in preview, this WebAssembly template, you need to install this using the .NET CLI, and there's instructions to do that on the official Blazor site, which is at blazor.net. So we can select a Blazor WebAssembly app. Now we've got a few options. So we've got this tick box down here for ASP.NET Core hosted. So if we tick this, we'll actually get a solution that's got 3 projects in it. We'll have a Blazor WebAssembly project, we'll have an ASP.NET Core Web API project, and we'll have a .NET class library that we can use to share code between those two. So that's tends to be quite a common template to use if you're doing something that involves persisting data to a database somewhere, or you need some server-side logic, things like that. We've also got this other one, progressive web app. So this is quite cool. If you're experienced web devs, then PWAs are probably quite a common thing. And we can just tick this tick box, and all of the infrastructure for creating a PWA is going to be baked into the template for us. So it's really trivial to get set up, which is really cool. And then finally, the other settings we've got up here is for authentication. So we can click change here, and we can set individual user accounts. Now, because I've got just a simple WebAssembly app template selected here now, if I do this, then this would basically set the template up so I could do authentication using an OIDC compliant server somewhere, so some identity server somewhere, something like that. But we don't need this for now. We'll ignore that, and I'll leave that up as an exercise for you to go and read about if you're interested in that stuff. There's loads of great information on the Blazor site. So I'm going to just create a simple Blazor app for us to look around in. Cool. So this is what we get as standard. This is a single project. This is a Blazor WebAssembly project. And in here, we've got a few different things. So let me just zoom in a bit here as well, just in case. So let me get rid of that. There we go. So we've got a www root folder. So this will look quite familiar if you're a Razor page developer or MVC developer. This has just got static assets in it. So we've got some CSS and some sample data, and we've got this index.html. And that's where our Blazor WebAssembly app is going to be hosted. So I'll show you that in a second. And then we've got this other folder called Pages, and this has got these .razor files in it. And these are Blazor components, or Razor components, as they're officially called. And we'll have a look at those in a sec. And then finally, we've got this shared folder, and this has got some shared stuff. So this is, we've got a layout component here, and a nav menu, and a survey prompt, and we'll look at those. Cool. So let's have a quick look at this index.html to start off with. This is where our app is hosted. So we start off with this reference, this Blazor WebAssembly JS file down at the bottom. So this is where all the magic happens. This boots up our app. And then in this, in the middle of this markup here, we've got this app tag. Okay, and that's actually where our Blazor app is going to load. So we actually we configure that in the program CS file. I'll show you that in a second, and tell Blazor where it's going to load up, what element to use. So if I open up program CS, and you can see this is where we do that on this line here. So what we're saying here is that the entry point for our app is this app component, which we're specifying by type here. And then we're saying load it into the app element in our index.html page. So that's where that happens. While I'm here, I'll point out the fact that there is no startup.cs. This is a relatively new change that came in a preview or two ago. Yeah, it makes sense really. I was really a big fan of this change. Normally in ASP.NET Core apps, we usually have a startup CS file, and in there we have a couple of methods. We have a configure method and a configure services method. The configure services method is used to configure the DI container, and the configure method is used to set up middleware and do all of that kind of stuff. Except in Blazor WebAssembly, we don't have middleware, so that method is kind of redundant, and it just probably makes things slightly confusing. So when you get rid of that, you've only got the one method left, which configures the DI container. And you kind of don't need a whole class for that in a separate file. So we now can do service configuration by just adding to the service collection here. So we can see in the default template, we have an HTTP client added into the DI already set up for us. So that's quite handy. So let's have a look at some actual components now. So in the pages folder, we have, like I say, these components. Now, these are officially called routable components. I think that's what they're referred to in the docs. I tend to call these page components because in order to sort of specify that these are a page in Blazor apps, we use the page directive here at the top, and we specify what route they're responsible for. So hence why I tend to refer to them as page components. So in here, in the little quotes bit, we say this is we specify the route that this particular component will be responsible for. So this one's a / so that basically means it's the root component. So this is like the home page, if you like. And then here we've just got some simple markup. We've got an H1 tag and some text. And then we've got a reference to another Blazor component. So this is a survey prompt, which is in our shared folder down here. So I'll quickly show you this one. And in here, you can see we've got a bit more going on. We've got a code block, and we've got this property decorated with a parameter attribute. So what's this all about? Well, this is how we define a public API for our component. So what we're saying here is that any consumer of the survey prompt component can pass in a title. Okay, and then we're going to just display that title up here when we get it, when the component's rendered. And if we go back to our index page, we can see we're just passing that in at the top here using this attribute style. So that's a nice simple way of passing data into components. If we look at something a little bit more advanced, I'm going to open the fetch data component here, and there's a lot more going on in this one. So we've still got our page directive at the top like we had before, but we also have this inject directive, and this is how we do dependency injection in our Razor components. So we're injecting in the HTTP client here, so we can use it inside of our component. We've got a little bit of markup here with some logic, some Razor logic. We've got an if statement and a for each that's going to print out all of the forecasts that we get back in our data set. And then down in the code block at the bottom, we've got an array of weather forecasts here. And then we've got this interesting method called onInitialized async. Now, this is one of the lifecycle methods that we have on Blazor components. It's one of three. There's onInitialized async, there's onParameters set, and there's onAfterRender. So onInitialized async is executed once in the lifetime of a component, and it's great for doing initialization logic, as the name suggests. So here, for example, we're calling into this sort of static JSON file we've got here to load our weather forecast data, but we could easily be making a call to a web API. The onParameters set, that's a method that's used in a much more specialized way, and it's to do with whenever incoming values to the component change, we can do logic based on those changes. And then there's like I say, onAfterRender, which is primarily used for doing JavaScript interop calls. So that is the fetch data page. So what I'll do is just run this up, and we can have a quick look at what this template looks like. That's the wrong screen. Cool. So here is our Blazor WebAssembly app. So we can click around, really quick, really sharp. We can click around in here, all works as you'd expect. I'm going to open up the dev tools now, and we're going to have a quick look in here. So what I want to just highlight at the moment is if we go to the network tab, I'm just going to disable my cache by clicking this box and do a quick refresh. And I want to highlight some of that stuff we talked about in slides so you can actually see it happening. So we talked about how that boot up process works. Well, we can see that we've got the initial document that we requested coming down here, and we've got those static files that we talked about. And a bit further down, we can see we've got this .net.wasm file that we talked about, and that's that mono.net runtime compiled to WebAssembly being downloaded into the browser. Then after that, we've got our application DLL and all of its dependency DLLs. So I wasn't messing about. We are genuinely running everything in the browser. We're executing these DLLs in our browser. So that is, I really like that. I think it's really cool. Interestingly, down at the bottom, you'll notice that it's quite hefty at the moment, 6.3 meg transferred. So this is, again, a more recent change. There's no compression, there's no IL stripping going on or anything like this at the moment with this app because we're running in debug. So the idea is to kind of spin these things up as quickly as we can, and we're not looking for optimal size or anything at this point while we're going through development. But if I close this down, and what I'm going to do is I'm going to chop over to release mode, and we'll run this up again. Let's take a second. So I'm just going to do the same thing again, and we'll refresh it this time. Now, we've got all the same stuff. We've got all those DLLs that we had before, and we've got that WASM runtime up here. But you'll notice there's a big difference in terms of size. We're now only transferring 2 meg. Now, that's quite impressive. And that's that IL stripping, that assembly shaking that we talked about right at the start in action. And you can see it really is a huge differentiator. It's knocked off 4 meg of our app. So that's really impressive. And in fact, if I take off, if I enable caching again and refresh, you'll notice that now I'm only transferring 33K. And that's because a lot of those DLLs and that WASM runtime and stuff can be cached by the browser. So while there can be a bit of a cost up front, it gets cached. It's a pay once cost. And we can mitigate that through things like CDNs and stuff like that longer term. So it's a quick whiz round the Blazor WebAssembly template and what we get out of the box there. So I'm going to just jump back onto the slides now. So let's just summarize this up. So Blazor WebAssembly runs on the client. It offloads work to the client, which is great for things like scalability. If we had an app that's only got really popular, the sort of load that we have to deal with isn't so bad if we've got a lot of logic sort of on the client, because it's the client machine that's going to be doing the grunt work, which is useful. We can make apps that work offline. It's really trivial to make Blazor WebAssembly apps into PWAs. So as we saw when we were looking at the stuff in Visual Studio, it's literally checking a checkbox to enable PWAs. And even if you want to sort of retrospectively add it into your app, it's really trivial to do. So that's a big benefit as well. It's deployed as static files. So this, like I say, as .NET developers, we now get access to free or cheap hosting, which is something we've not had to have before. We don't need a .NET runtime running on the server. And again, I'm going to hammer this again, code sharing. If you're running C# on your API, then you can share code between that and your Blazor WebAssembly app. And that can make life a lot easier. So that's a really big win as well. As I said, Blazor WebAssembly is currently in preview, and we should see that in May. I would look out for that build probably. Current payload, about 2 meg, but there's more improvements coming. If you saw the latest ASP.NET community stand-up, Daniel and Steve were both on there, and I believe with Brotli compression, which I think is being added now, the size can go down to like 1.6 or 1.4 meg or something like that. So there's another big saving on size coming as well. So that's great. And then we've got load time. So load time can be sort of it can be slow sometimes depending on what the connection is. If you've got a really, really slow connection, because we have got to download that runtime, you could notice a bit of a delay with an app booting up. It really depends on your scenario. And it's worth noting you are running in a restricted runtime. So you're running in the browser sandbox. You're limited by the same security implications as any JavaScript application. So no reaching outside and playing with the client's file system or registry or any of that fun stuff. So yeah. So that's Blazor WebAssembly. So let's talk a bit now about Blazor Server, and we'll have a look at the differences. So we're going to go through the same exercises that we went through for Blazor WebAssembly and sort of see how this works in comparison. So we'll go through the boot up sequence. So we've got our browser on the left again, but this time we've got our web server and we've got our Blazor app over there because Blazor Server executes on the server, hence its name. So when we make a request for our app to the server, we get some files back. We get HTML, CSS and images and JS files and things like that. And we get some HTML back as well. And that's all going to get rendered, and our DOM's going to get constructed and things like that. And then we're going to execute this file called blazorserver.js. And the job of that is to establish a signal R connection between the client and the server. And once this is done, then everything from this point forward is going to execute over that signal R connection. So I'm going to skip a couple of bits because I've updated these slides. So going to jump us over to the same search results scenario that we were looking at with Blazor WebAssembly. So how does this work in Blazor Server? Well, same scenario as before. We're going to click that load more button. That's going to get that DOM event will get intercepted, except this time it just gets transferred straight over that SignalR connection back to Blazor running on the server. So once it's over there, it's going to do the same thing before. It's going to call into our application code and find the handler, execute the handler that we have for that click event. So again, we've got our same search component, except this time around, we're probably not going to be executing an HTTP call to get some stuff from a web API because we're already on the server. So we'll probably go off to a service somewhere to get data from there or something like that. And again, when that comes back, we'll update the list of search results on our component. And again, that will be a state change in our component, which will trigger Blazor to do a re-render. So that's what happens next. And again, Blazor will create a render batch of changes that need to happen. That render batch is going to get sent back over that SignalR connection, back to that small Blazor runtime that's running on the client. And that is then going to apply those updates to the DOM. And then we see the changes in our browser. So you can see it's very, very similar to WebAssembly. It's just kind of stretched out over that SignalR connection. So let's have a look at Visual Studio and have a look what a Blazor Server app looks like. So I'll close this solution down and we'll create a new project here. And we will select a Blazor Server app this time. So again, we've got options here with authentication. So if we want a template with auth enabled out of the box, we can. We've got individual user accounts, which is using the identity membership system that's baked into, or that's we're used to with ASP.NET. We can also do stuff with Azure Active Directory and Office 365 integration, all that kind of stuff. And then we've also got Windows auth as well. We can turn all those on just by a few clicks, which is really cool. But we'll just go with the standard template here. So hit create again. Now, the structure is going to look very, very similar to what we just looked at. So we've got a www root folder and we've got pages folder and a shared folder and all that good stuff. So I won't go into loads of detail about those bits. We've just looked at those. One thing I will point out is in the www root folder, we actually don't have an index.html page here. Instead, in the pages folder, we have this host.cshtml, which is actually a Razor page. Now, if we open that up, this is where our Blazor Server app is hosted. Now, slightly different to Blazor WebAssembly, we have a tag helper here called component, and that's sort of saying where our app is going to render. So again, we specify the entry point for our app, which is our app component. And you can see by default, server pre-rendering is turned on for Blazor Server applications. But other than that, the components are exactly the same. If I open up the index page, you can see it's absolutely identical to a WebAssembly version. If I open up fetch data, again, very, very similar. The only difference here is that in our onInitialized async method, we're going to this forecast service and we're injecting the forecast service here at the top instead of an HTTP client. So yeah, everything's pretty much exactly the same. So that's really cool. While I'm here as well, I'll show you the app component. I didn't show you this in the WebAssembly app, but they're exactly the same. The app is the entry point by default for a Blazor app, and it contains the router component. Okay, and the router component is the thing that's responsible for loading the correct page based on whatever route that we're trying to access. So any pages that it does find, when it looks for them, it will get loaded here using the found template. And if we request a route that there isn't a page component for, then we'll hit this not found template, and we'll kind of get this nice friendly message saying that there's nothing at this address. So that's what's in the app component. You will notice as well, we do have a startup file for Blazor Server apps, and that's exactly the same as any other ASP.NET template. So we've got our configure service method, our configure method here. So if we spin this one up and have a look at it, so you'll notice that the project templates are exactly the same. And if I click about, you'll notice the actual user experience is very much the same. Now, I'm not sure if this translates as well over a Zoom call as it does in real life, But trust me, clicking around here is just as quick and snappy as it was with Blazor WebAssembly. I can click the counter like I did before and increment the count, and then we can load that data on that fetch data page. In fact, I'd go as far as saying that if I gave you a Blazor Server app and a Blazor WebAssembly app and put them side by side and I didn't give you access to the browser tools, I would bet you would never be able to tell the difference between the one that's running entirely on the client and the one that's going back and forth to the server. It's that sort of efficient. So that's a really neat thing. So let's have a look at the inner workings of this. Well, for starters, if I just do a quick refresh, you'll see that there's a lot less files downloaded, okay? As we saw when we were looking at the slides, there's not so much needed to bootstrap a Blazor Server app because the majority of things are running on the server. So we have some CSS files, and we have our Blazor Server.js, which is going to establish that WebSocket connection back to the server, which we can see right at the bottom here. Now, what is quite cool with Blazor Server is we can actually see what's going on. So we can look at these binary messages, which are sending back and forth between the client and the server to sort of transmit UI events back to the server and renders back down to the client. So I'm on the home page now. I'm going to clear this out. I'm going to click on the counter and I'm going to click it a couple of times. And you can see those binary messages racking up. And every time I'm doing this, the event is being sent back to the server for a UI update to be calculated and then changes to be sent back down. And as I said, we can actually inspect this stuff. So if I click on this first message and I go down here, we can actually see what's going on. So we've got this dispatch browser event down here, and we can have a look and we can see that it's a mouse event, and a bit further down we can see that it was a click event. So that was when I clicked this counter link. And we've got metadata about XY coordinates of where I clicked on the screen, and if I had any sort of meta keys held down like Control or Shift or anything like that. And at the bottom there's an on location changed event included as well, and that says where we're trying to get to. So you can see down here localhost /counter. So that was when we're clicking that counter link, and that's where we're trying to get to. Now, if we look at a couple more of these binary messages, there's one that's a little bit more interesting, and that's this one. So we can see a render batch. I mentioned earlier, these changes that are calculated by Blazor, they're bundled up into something called a render batch, and this is one of them. And if we scroll down, we can actually see what's in it. So we're on the homepage. We clicked on the counter page, and as I said, Blazor calculates the minimum amount of changes that we need to do to make the UI look like, well, take it from what it did look like to what it needs to look like. So in this case, we needed to update the H1 tag to say counter up the top here. We needed a P tag with a current count of 0, which was obviously here before I clicked it 4 times. We also wanted to render a button, and we wanted a class, and we wanted a couple of classes added of BTN and BTN primary, because this is using Bootstrap at the moment. And then there's an on-click handler for that button, and then there's some text for that button called click me, and you can see all that there. So you can see that's all bundled up into that binary message. Okay, so it's really efficient, really minimal amount of stuff here, and these messages are tiny, so 600 bytes there for that update, so to change that page. And if I keep going down here, you'll see there's stuff further down where I've clicked things, and we'll see like the count numbers going up. So down here, I've clicked it, and then you can see the count is changing from 0 to 1 there, and that carries on down. So we can see all that stuff going on. So we are genuinely going back and forth between client and server for every little change, but really quickly, really efficiently. So let me jump back into the slides now. So this is usually the next question after showing that. But can it scale, and what's the performance like? Well, these are quite understandable questions. That does sound a bit odd to us, I guess, as developers, to have all of that back and forth. It sounds very chatty. But actually, that Blazor Pack protocol that's being used is very, very efficient and very, very quick. But the team did some work on this, and they've released some figures. So on a standard D1 V2 instance in Azure, which is 1 virtual CPU and 3.5 gig of memory, there were over 5,000 concurrent users could be supported on a Blazor Server app. Now, these aren't just idle connections. These are actually active connections to that application. So that's a pretty impressive feat. Pushed it a bit further and looked at a standard D3 V2 instance, which is 4 virtual CPUs and 14 gig of memory. And that could support over 20,000 concurrent users. Now, that's pretty impressive. And I've never worked on an app that is needed to support 20,000 concurrent active users. So for me, that kind of removes my question around the scalability of Blazor Server. But there were some other interesting findings about that, and I'll touch on them in a second. So to summarize Blazor Server a little bit. So it's production ready. It was released with .NET Core back in September of 2019. So it's been around for a little while now. So much smaller payload when we first load a Blazor Server app. Okay, so we've got no runtime to download this time. We can just literally render that HTML that's coming down from the server and off we go. Fast load times, again, as I said, everything's pre-rendered by default on the server, so makes it boot up very, very quick. We have access to a full runtime now as well. Because we're running on the server, we get access to all of .NET Core 3 runtime. We're not running in a browser sandbox or anything like that anymore. And this is one that didn't occur to me at first, but code security. So with Blazor WebAssembly, we are downloading all of your DLLs and everything into the client's browser, which means that they're vulnerable. They can be decompiled and stuff like that. So if you do have any sort of intellectual property, any code that you want to protect, Blazor Server might be a better choice for you. All your code stays on the server and nothing ever gets sent down to the client. However, the trade-off is, of course, that we do have now a heavier load on the server. The server's got to do all the work, and the clients are just more like thin clients displaying the data. Blazor Server apps also don't work offline, okay? So the moment there's a disconnect between the client and the server, you'll kind of get this opaque overlay on the screen saying that the connection's been lost and it's attempting to reestablish the connection. And if it can't, you have to reload the app. So if you've got sort of fragile connections, then Blazor Server possibly isn't the best choice. Also, latency matters quite a lot with Blazor Server. So this is part of the testing that the team did. That they found that I think the sweet spot was the high end was around 200 milliseconds. Anything more than that, and there was kind of a perceivable lag on the UI. So that tends to mean that you want your clients and your servers to be in the same continent, really, when you're setting up your infrastructure. And that, based on all of that above, it really means that you need kind of a fast and stable internet connection for Blazor Server. You kind of can't have intermittent connections or really, really slow connections. That's not a great use case for Blazor Server. So we've kind of covered Blazor WebAssembly, we've covered Blazor Server, and hopefully we now know some real nitty gritty about how both of those models work and how a bit about what Blazor is in general. So I just want to sort of finish up by turning attention really to the future of Blazor and I guess answering the why is it so exciting part of the initial title of this talk. So the future of Blazor, there's a couple of experimental hosting models for Blazor. So one of them's actually been around for quite a long time, and that's this desktop experimental model. So this has been done with Electron, and it was actually done by the team doing a hackathon, I think. And it's been around for a while, probably a year, maybe longer now. And this is available on GitHub. You can clone the repo and run this, and it's all good to go. And this runs Blazor components inside Electron shell. More recently, there's a slightly newer version, I guess, if you want to call it that, of this experiment. Steve, I think, was bored on his plane journey back from Sydney or something at NDC Sydney last year, and decided that he would improve on some of the shortcomings of Electron. Anyone who's used Electron will know that it kind of can be a bit bulky. It's got Node.js in there and Chromium and stuff, so it makes it quite heavy and quite memory intensive. Steve came up with this other idea called Web Window, and basically stripped out Node, stripped out Chromium, and replaced it with .NET Core, and kind of delegated the UI side of things to whatever the native web renderer was for the OS. So shrunk the size of the app quite considerably, and the memory usage, it was really some impressive performance improvements. And again, it just runs normal web-based Blazor components. That's available, I think, on Steve's blogged about it on his blog, and there's also, I think it's available on his GitHub as well, I think, or on, I believe that's where it is anyway. So yeah, can you check that out as well? So that's quite cool. And with both these desktop experiments, components are written the same way. So we have web-based components. So this is the same counter component that we saw right at the start of the talk. This would execute perfectly fine on those hosting models, those desktop-based hosting models. But then there's this other one, and this is mobile. So to give it its full title, this is Mobile Blazor Bindings. Very experimental, very new. There's only been a couple of previews of this. If you're really interested in this, I'm actually exploring this myself at the moment. I'm writing a blog series. I've published the second part of it today on building Blazor mobile Blazor binding apps for web developers. So please check that out on my blog if you're interested. But this one's a bit different. This is something different to the other models I've been talking to you about. And components here are written slightly differently. And that's because we're using the Blazor component model to output native mobile UIs. So this is that same component now for mobile Blazor bindings we've been looking at, the counter component, except we're not using HTML anymore. What we're actually using here is native mobile controls, so stack layouts, labels, buttons. Now, under the hood, what this is actually using is Xamarin Forms components. And this has been done in collaboration with the Xamarin team, so don't think that the Blazor team is silently trying to kill off the Xamarin guys. It's in collaboration. Yeah, this allows us to use the same programming model that we have with Blazor, but we can, like I say, create native mobile UIs. And you can see the similarities. There's the markup section at the top and the code block at the bottom. And you can see that the code block at the bottom isn't even changed from the web version. But you can see all the similarities here. So we've got that razor syntax for printing out the current count. We've got that on-click handler for the button that's calling that increment count method. Okay, so the great thing here is that if we've learned how to build applications with the web aspects of Blazor, it's really, really easy to move that knowledge over to building native mobile apps. And as I said, this is something I'm exploring personally at the moment, and I'm really enjoying it. I found it really quick and easy to pick up, and I've already managed to build a little fun sample app. So I'm just going to quickly jump out and show you that one just to round things off. So I'm going to jump over to my other Visual Studio, and this is something called Budget Tracker, which is a simple budget tracker app. Where am I? Oh, I'm on the wrong screen. Here we go. So in here, we've got components like we saw before. So we've got this razor component here, various razor components, bits and bobs. I personally like using feature folders to construct apps. So that's why this is all done like this. But if I open these up, you'll see it looks very, very similar to what we've just been looking at in the web world. So here's all these various components. These are all custom components that I built here, expense list and create expense and stuff like that. But the programming model is exactly the same. Okay, there's a lot of familiarity here. You can see the same attribute style for passing in information into my components. So it's really intuitive. And I'll just spin this up really quickly, and hopefully we'll be able to see this running. I won't kill my machine. So let me drag this up here. So here we go. This is just like I say, a simple little budget tracker app. So I can set my budget here and okay that. And then you can see that all dynamically updates. And I've got my balance and my budget and my expenses, and I can click my add button. I can record my expenses. So I did some shopping and that costs a bit of money there. So that's all good. And I can hit save and add that to my list. And you can see this all updates. And this is using all of Blazor's normal logic for calculating UI updates. I'm not doing anything special here. I'm just changing values, and Blazor's automatically updating all the values for me and stuff like that. So like I say, naughty little app, but it was really quite quick to get going with this. And like I say, really enjoying that. So like I say, if you want to see more, please check out my blog for that current series. So I'll stop that running now to try and save some memory on my machine. And we'll jump back to the slides just to finish up. So let's get this going. So what I want to leave you with, and the kind of closing thought for you to take away is this. .NET is your platform for building anything. We can build desktop, web, cloud, mobile, gaming, IoT, AI. We can do whatever we want. We can learn that one platform and produce all of these cool apps across all these different platforms. And the question I have, I guess, in the end of this is, does that mean that Blazor is going to be our framework for building any UI? Whether it's desktop, it's web, it's mobile. Can we learn that one framework, that one way of building UI, and apply that to all of these different types of applications? I hope so. I don't know what's going to happen, but that's my hope, and yeah, something to ponder on. If you're getting into Blazor, I'll just finish up with some resources here. So we've got the official Blazor site, and there's the MS Docs site as well that you can get to from here. Loads of great information on there. The MS Docs sites are amazing. There's also Awesome Blazor, which is a community project. It's curated by a guy called Adrian Torres. I know Adrian, he's a great guy, puts a lot of time and effort into this repo. It is full of, it's a treasure trove of Blazor information, projects and samples. It's really worth your time checking out. Blazor's got a really active Gitter channel as well. So if you want to go and talk to some people about some problems you're having with Blazor or discuss things, that is a great place to do it. Blazor University is a community site project done by a guy called Peter Morris. It's a great little reference site. Loads of information about how Blazor works and all of this kind of stuff is covered on there. And then finally, you've got my blog. Like I say, I've got a couple of years worth of blog posts on Blazor, so hopefully there'll be something useful for you in there. And I tend to blog once a week with new stuff. So that kind of wraps things up, I think, for me. So we'll move into sort of any questions and bits and bobs from here.